All right, so today we're diving into something pretty mind-bending.
Yeah.
Quantum computing and machine learning.
Really fascinating stuff.
You guys sent us some research by Jorgo Schneepat
Yeah.
on quantum kernel methods.
It's cutting-edge research.
I have to say, even the title sounds like something out of a sci-fi movie.
Well, it kind of is. It's about how we can use quantum mechanics
Wow.
to make machine learning even more powerful.
Okay, I'm hooked already, but
Yeah.
I think before we go full-on quantum,
Sure.
can we back up a bit?
Absolutely.
What exactly are kernel methods,
Okay, good question.
and why are they important now?
Yeah.
In regular computing, I mean.
Right, so kernel methods are like a fundamental tool
Mhm.
in machine learning.
Got it.
Imagine you're trying to find patterns in data,
Mm.
but the data is just all over the place.
Mhm.
Kernel methods give your computer a way to see that data
Okay.
in a higher dimensional space.
So instead of just looking at it flat,
Yeah.
we're adding another dimension.
Exactly. Like going from 2D to 3D.
Ah, I see.
And in that higher dimension,
Yeah.
relationships in the data that were hidden before can suddenly become clear.
Okay, so is this like
Right.
if you had red and blue marbles all mixed together?
Yeah, yeah.
It's hard to separate them on the table, but if you tossed them in the air,
Perfect analogy.
they might separate as they fall.
Exactly.
That's not how heavy they are.
Yeah, that's the power of kernel methods.
So they're already being used in things like
They are.
facial recognition or
Yeah.
product recommendations. Like
Yeah.
those, you might also like things.
Yeah, things like support vector machines
Right.
or SVMs and kernel PCA use these methods.
Got it. So kernel methods are already doing pretty amazing things.
Yeah, they are.
But how does quantum computing take it even further?
It's about qubits.
Qubits, yeah.
Remember, they can be in multiple states at once.
Right, unlike our regular bits,
No.
which are just 0 or 1.
And then there's entanglement, where they're connected in this, like, spooky way.
Yeah, it's almost like
It is mind-boggling.
they're linked,
Yeah,
even though they're separate.
exactly. It's super weird.
So Schneepat is saying
Well, he suggests.
that if we represent data as quantum states,
Mhm.
we can explore relationships in even higher dimensions
Right.
than a classical computer ever could.
That's the idea.
So not just 3D,
No.
but we're talking
Way
dimensions that are hard to even picture.
Yeah, it's hard to wrap your head around.
It's pretty wild.
And Schneepat thinks this could help us solve problems that are impossible for regular computers.
Like what kind of problems?
Well, imagine analyzing huge data sets,
Yes.
like all the genetic information in a population to find patterns that could revolutionize healthcare. That's the kind of power we're talking about.
That's incredible.
Yeah.
So how does Schneepat actually
So how does it?
put this into practice?
Well-
Like, what are the specific algorithms he's developed?
Well, one of them is the quantum support vector machine,
Quantum support vector machine.
or QSVM for short.
It's-
It's basically a supercharged version
Hmm.
of the regular SVM we talked about.
So it's like taking the existing kernel methods and giving them
Quantum boosts.
a quantum boost, exactly.
Yeah.
And what can we do with that?
All sorts of things.
Like what?
Imagine sifting through mountains of data
Okay.
to find the absolute best way to
Yeah.
classify information,
Hmm.
whether it's spotting fraudulent transactions
Well-
or predicting how well a new drug will work.
That's pretty amazing.
It is, and there's more.
Oh, there's more.
He also explores something called quantum kernel alignment.
Quantum kernel alignment.
Think of it like a microscope
Okay.
that can adjust its focus to get the clearest image.
Hmm.
This algorithm does something similar.
Okay.
It refines how the data is represented.
So it's like fine tuning.
It is, yeah.
How we're looking at the data.
It helps us see the most meaningful patterns.
So it sounds like Schneepat is giving us
He is.
a whole new way to explore and understand data.
It's exciting stuff.
But before we go any further, I have to
Okay.
ask about
Yeah.
the challenges.
Of course.
Because I'm assuming
Right.
quantum computing isn't just a magic wand.
It's not magic, no.
That solves everything, right?
You're right, it's not magic.
So what are some of the
Well, for one,
roadblocks?
scalabilities.
Scalability, okay.
We just don't have quantum computers with enough qubits yet
Enough qubits.
to handle the really massive data sets.
Right, so it's like having
Yeah.
this incredible engine,
Exactly.
but you're trying to put it in a tiny car.
Perfect analogy.
The potential's there,
It is.
but the tech just isn't quite ready.
That's a big part of it.
Okay, and what about other challenges?
There's the issue of noise. Qubits are super sensitive. Any little interference can mess things up.
So it's like trying to do a math problem.
It's like that,
Yeah.
yeah.
while someone's shaking the table.
Exactly.
You can't concentrate.
It's hard to get accurate results.
So we need to make them more robust, more reliable.
Exactly.
But even with these hurdles,
yeah,
Schneppet seems pretty optimistic.
He is. He sees huge potential
about quantum kernel methods.
Yeah, especially for fields like medicine and material science.
Okay, let's talk about some of those applications.
Sure.
You mentioned healthcare earlier. And I gotta say, the idea of quantum computers helping doctors diagnose diseases earlier.
It's a big deal.
That's pretty amazing.
It is. Imagine being able to analyze medical images.
Like what kind of images?
Mammograms, MRI scans.
Okay.
With way more detail than we can today.
So we could catch things.
Potentially, yes.
Earlier that we miss now.
That's the hope.
Are there any examples of this actually happening?
Well, it's still early.
Right.
But some groups are using quantum computers to study protein structures.
And how would that help?
Well, understanding proteins is crucial for developing new drugs.
I see. So it's all connected.
It is. It's all about understanding the building blocks
of life
at a deeper level.
So it's not just medicine.
It's not.
Schneppet also talks about material science.
He does.
Which sounds just as mind-blowing.
It is. He points out that designing new materials is a fundamentally quantum problem.
In what way?
The properties of a material.
Like strength, conductivity, things like that?
Exactly. Those all come from how the atoms and electrons interact.
Got it.
And those interactions are governed by quantum mechanics.
So instead of experimenting in a lab...
Well, we'll always need experiments.
Right, of course.
But imagine being able to simulate how different materials behave.
At the atomic level.
Yeah, before you even make them.
I could revolutionize.
It could.
So many industries.
Absolutely, from aerospace to energy.
It's incredible.
It really is. Schneppet even talks about using this to understand the universe itself.
Whoa, now we're talking.
I know, right?
So how could quantum computers...
Well, think about the big questions in physics.
Okay.
Like dark matter, the origin of the universe.
Yeah.
Those involve quantum phenomena.
And we could... Potentially?
Potentially, yes.
Simulate those with quantum computers?
That's the idea.
To gain a deeper understanding.
Exactly, to explore things that are just beyond
the reach.
Beyond the reach of classical computers.
It's almost too much to take in.
I know, it's a lot.
All this potential.
It is.
But it makes you think about
it does.
The ethical side of things, too.
Absolutely, that's crucial.
Especially when we talk about AI.
Yeah.
That could be more intelligent than humans.
It's something we need to consider carefully.
So we need to think about not just what's possible, but also what's responsible.
It's a balancing act.
Absolutely. So what does Schneppet see
Well, he believes
as the future of this field?
That quantum computing will become more accessible.
More accessible.
Yeah, not just for researchers.
So more people will be able to use it.
Well, more people will be able to use it.
He imagines quantum kernel methods being used for everything.
Yeah.
Personalized medicine, sustainable energy.
So it's not just a theoretical thing.
It's not, no.
It's something that could really change the world.
That's the potential.
But with all this complexity, how can the average person
That's a great question.
even begin to understand it? Yeah, that's a question I've been wondering too. It's so fascinating.
It is.
But also pretty overwhelming.
Yeah, I get it.
For those of us who aren't, quantum physicists.
Right.
How can we even start to grasp all this?
Well, Schneppet talks about the importance of making this field accessible.
Accessible, okay.
He thinks demystifying quantum computing is crucial for its future.
So we don't all need to become quantum mechanics experts.
Not at all.
To understand what's going on.
No. And there are more and more resources out there.
Oh, that's good. For people who want to learn.
Like what kind of resources?
There are online courses, platforms that offer a good introduction, even if you don't have a science background.
So just getting a basic understanding can help us appreciate the potential.
Exactly.
And maybe even discuss the ethical side of things.
It's all connected.
So where should someone start?
Well,
are Schneppet's papers a good place?
Schneppet's papers are actually pretty readable.
Okay.
He's a good writer, explains things clearly.
But maybe not for a complete beginner.
Right. For beginners, there are other options.
Like what?
Platforms like IBM Quantum Experience.
IBM Quantum Experience?
They have interactive tutorials.
Cool.
You can even try writing some simple quantum programs.
Wow, so it's getting more hands-on.
It is.
Like learning to code.
Kind of, yeah. But for quantum computers?
That's amazing. And I bet there are tons of articles and videos online too.
Oh, yeah. Tons. Just got to find the right level.
For your understanding. It's great that this knowledge is becoming more available.
It is. It's exciting.
But I keep coming back to this question.
What's that?
If these computers can process information so differently,
Right.
could they help us understand some of the biggest mysteries of the universe?
Schneepat thinks so.
It's a big question.
It is. He's fascinated by it.
It's kind of mind-blowing to think about.
It is.
We're not just talking about faster computers.
No.
It's a whole new way of seeing the universe.
And our place in it.
It's humbling.
It really is, and it reminds us
Of what?
that we need to approach this technology carefully.
Yeah, with a sense of responsibility.
Exactly.
Well, this deep dive has definitely given me
too.
a lot to think about.
A lot to ponder.
We've gone from the basics of kernel methods to the mind-bending world of quantum computing.
And the possibilities are
incredible.
Endless, really.
It's going to be interesting to see.
It is.
Where it all goes from here.
I have a feeling we'll be hearing a lot more about quantum computing, quantum kernel methods in the future.
It's a field with so much potential.
So much.
Well, that's it for this deep dive.
Thanks for listening, everyone.
We hope you enjoyed our exploration
of Schneepat's research.
Until next time, keep learning,
keep questioning, and keep diving deep.